Okay. Now, the radio itself, let's take a look at it. Well, I'll just explain it. This is the firmware for the radio. It's actually the control software, the user interface, if you will, between the joysticks and the on-screen display and the buttons and the actual hardware radio that broadcasts the signal. So inside or outside of each remote controller these days, it's possible to have different radio standards that's based on different hardware and different protocols. So you all know Wi-Fi, you all know Bluetooth. Those are some options. They're meant to be high bit rate, but not long range. And historically, there have been many different protocols and hardware. And the one we're going to use is called ExpressLRS. And this radio has this remote controller has ExpressLRS built inside of it. So that radio on the inside also needs its own firmware. So it's kind of like updating the graphics card on your computer, where you have a very fancy piece of hardware inside of this remote controller that's a LoRa protocol. The software is called ExpressLRS, so we need to update the ExpressLRS software for that particular radio that's inside of the computer. So we do that by going to, so these are goals: update the firmware on the ExpressLRS module inside the radio to the latest version using USB cable. Then we need to download a Lua script to the radio to the radio controller that controls the hardware on the inside with with the Lua script. Lua is a simple language like Python. And then we also need to set the binding passphrase, which is like your password that your drone receiver and the radio transmitter both share the same passphrase, so that your drone knows which radio to listen to if many radios are on at once. Okay, so first we have to download the configurator. So let's go to the ExpressLRS website, ExpressLRS.org. I think this is it. It's probably, okay, here it is, except cookies. So this is the project. This one also is an open source project on GitHub. And here's the GitHub repo, ExpressLRS/ExpressLRS. So this is only for the hardware radio and the transmit and receive side. It's not for the interface, the buttons and stuff that you use. And here's the features. Again, you can mod this to your heart's desire because it's open source. Okay, so what are we going to do? I guess let's go to instruction. Let's look at quick start just briefly. Here's a quick start. And let's look at all right, let's just on the transmitter side. Okay, so first on the transmitter side, we have to set up a radio. And then check the transmit firmware version. That's what we're going to do now. So in order to do that, I think the easiest thing is just download the ExpressLRS Configurator, which is on GitHub. So this is the most recent release. And we're going to download the .exe file for Windows, ExpressLRS Configurator setup.exe. I guess that's what we need. Let's do it. And Windows is probably going to be plain. I don't want that. I want the downloads. All right, so it didn't complain, so that's the setup. Anyone? Yes. Install. So the instructions on how to flash the firmware for the hardware radio inside of the radio controller are at this link. It's under the quick start. Quick start, updating transmitters. These are all the transmitters that it supports. So we're going to do internal radio masters. So the radio is internal. Some of them have a radio module that's external to the radio controller. It plugs into the side because there's different protocols. ExpressLRS is the most common one used these days. It's very long range, it's very low cost, and it's open source hardware and it's open source software. Okay. Advisory, make sure that you are not upgrading prior to version 2.5.2, which we don't have. Okay. So we're going to flash it, not over Wi-Fi. One nice thing about all this ExpressLRS hardware is that it uses ESP microcontrollers. It's like an Arduino microcontroller. It's like an STM microcontroller. However, it's made by a company called Espressive, and those microcontrollers have onboard Wi-Fi. So it's very nice, and they can be their own web server. We're not going to do that here. We're going to do everything over the wire, but in the future, you can look through the documentation, and in some cases, it may be more convenient to do it via Wi-Fi. When you're at a university like UC Irvine, the Wi-Fi connection is not managed by you. It's managed by the IT department, and the Wi-Fi password is sometimes different. So we're going to avoid that and just do it by wires today. So we're going to do it via EdgeTX pass-through. So EdgeTX, like I said, is the UI software on the radio, and it's passing through to the internal radio. So these are the directions on how to do that. And let's see what they say. Before you start, make sure you have the correct version of EdgeTX. So we do. We just did that. Hot tip. Make sure you have an internal ELRS module on your radio. We do. We bought one with an internal ELRS module. Current model on the radio should be using the internal module, which it is. Let's just talk about that briefly. In order to do that, you can go to your radio. So power on your radio, press the MDL button, model, select one of your models. It'll be the default one, probably called Pocket. Right click the, oh wait a minute, that's not what we want to do. Okay, let's go back, so return, go to System. No. How do I do this? Module. No, I don't want that. System. Uh-oh. Okay, I'm going to have to pause for a moment and check this. Okay, here we go again. You can fact check me with a clock down here. It took me a few minutes to find out how we're going to proceed. So let's go back to where we were. We so far have downloaded onto this radio, we've downloaded the EdgeTX software. Oops. We downloaded the EdgeTX software and firmware and to the radio. EdgeTX, like I said, is like the UI interface. It's kind of like the operating system for the radio. And that we did. The next step that we got stuck on a few minutes ago was to apply the firmware to the actual radio hardware inside of the radio controller. It's an internal module. Like I said, just like a computer has an internal GPU that sometimes you want to download firmware for, drivers for, we're downloading firmware to the internal radio which is based on LoRa protocol, and it's a chipset based on ESP, which is a microcontroller that has onboard Wi-Fi, which we're not going to use. So we downloaded the ExpressLRS Configurator, but before we connected that to the radio, we got stuck on this issue that they mention here. Before you update the firmware, make sure that the current model on the radio should be using the internal ExpressLRS module. So here's what that means in plain English. Let's say you have a bunch of drones, drone 1, 2, 3, 4, 5. Some's fast, some is slow, but you only want to buy one radio controller. Well, you can program your radio controller so that there's a model number or name for each drone that you have. And you can call it my first drone, my second drone, or my fast drone, my big drone, my small drone, etc. And we're going to go over that in the future. But this is kind of a chicken egg problem. They're assuming that we already have a model programmed into the radio and that we have it configured to use the internal ExpressLRS module, because you can buy, if you want, an external radio module of any protocol that you want, plug it into the back of your radio, and use the external one. So what they're saying is make sure you have the internal one selected before you flash the firmware. So the way we do that is by running a script on the radio called ExpressLRS Lua script from the tools menu of the radio itself. Now, here's the problem. So let me show you the problem.
Disarmed. Stabilize mode.
I'm going to power on the radio. I'm going to select and plug it into the computer. I'm going to select USB storage so that I can access the radio's SD card. So it's going to be mounted as USB-D. I'm going to look at it. And there's a scripts folder. These are all the scripts, Lua scripts, that you can run on the radio. And there's various types of scripts. We want tools. There's one called Snake. Let's just look at that for fun with Notepad. So Lua is a simple programming language. So here's a program for Snake that you can play that game on your radio. That's there. So what we want is the ExpressLRS Lua script, which somehow is missing. I don't know how it got deleted. It was on there before. Luckily for us, we backed up the SD card. So this is the backup from before we started this whole process. And this is how I'm going to solve this problem. You're going to always run into problems. There's various ways to solve them. And part of the process is getting problem-solving skills. So this backing up your configuration files before you do any firmware update is always an important thing to do, and this is a good lesson. So in the old configuration file under scripts tools, we had all of these Lua scripts. So again, I apologize. I don't know how they got deleted from my radio when we flashed EdgeTX. I just don't know what happened there. If somebody can figure out, let me know. Anyway, so we need this one called ExpressLRS version 3.lua. So we're going to copy that over to the SD card on the radio. So this is the local backup on the local disk. This is the SD card on the radio. You can also play Pong. You can play Asteroids. And you can play other games. So we'll put Pong on there just for fun. Like I said, I don't know how that got deleted when we installed the upgrade to EdgeTX. But luckily we have a backup. So now we have that script on the USB drive, which is the SD card in the radio. So now I'm going to unmount the radio, eject it, and now let's go back to the directions of what we have to do. So I'm going to disconnect the radio.
Disarmed. Stabilize mode.
Before we flash the new firmware, it says the current model on the radio should be using internal ExpressLRS module. Test this by loading the ExpressLRS Lua script from the tools menu. So again, I don't have a video recording of the radio, but I'm going to tell you which buttons to press. Press the system button on the radio, SYS. Now my game is on there, Asteroids, Pong, and also my ExpressLRS Lewis script is there. So by moving the roller on the right bottom right hand side and selecting the ExpressLRS, click the roller, it will run that Lewis script. Now it's running that Lewis script, and that tells me to use, that will tell the radio to use the internal module, RF module, by running that script. So that's all we needed to do. Now I'm going to scroll down, click exit, and click return, which is the top left button. So now we have done that, and we are using the internal ExpressLRS module, and we can proceed. Okay, so the other thing it asks you to do is to set this interface setting, which is default set on your Radio Master already, so we're going to skip that. If you want, you can double, triple, quadruple check that. But I did check it. It probably would be good for you to check it. So now it says, now we're going to keep following the directions. Connect your powered up radio via USB cable. Okay. Now it says collect USB serial VCP. Now that's going to tell the radio to send any USB commands directly to the internal RF module. And on your computer, check whether your radio is being recognized. That's the module internally. So now I'm going to go to the device manager. And there should be a COM port called STM Electronics Virtual COM port. So that's a port that allows our computer to connect all the way into the deep internal hardware of the radio controller and talk directly to the RF hardware, the ExpressLRS transmit module. So that's working. Now it says launch ExpressLRS Configurator. So let me make sure we're following the directions here. Power on radio. So this is an abbreviated version of those directions. Power on radio. The current model on the radio should be using internal. We did that. Connect the USB cable. We did that. Choose serial on the radio. We did that. On the computer, check whether your radio is recognized as a virtual COM. We did that. Follow the on-screen instructions to flash to COM 3. Okay, which is what they're telling us to do here. So let's do that. Here's the ExpressLRS Configurator. Well, okay, basically just an interface. So what we need to do is listed in detail. There's all these options, and here are the options that we want. Device category, let's do that first. So the device, we're going to use the most recent version of ExpressLRS 343, and we have to pick which kind of hardware we're going to burn it to. So device category is Radio Master, and we have a 2.4 gigahertz module. So that's the general category. The actual device, because there's a lot of 2.4 gigahertz radio modules, is the Pocket Internal 2.4 gigahertz. Okay, we're going to flash it using Edge TX pass-through, and the regulatory domain, we don't want European Union, we want ISM. That's the international regulatory domain. Binding phrase is up to you, and you need to put this both on the transmitter and the receiver. They have to have the same binding phrase. Please make note of that. Pick a binding phrase, write it down. UART inverted, I guess we want. The rest of these we're going to leave alone. We're not going to play around with the Wi-Fi, like I mentioned. And now we have to pick the COM port. Uh-oh. And it doesn't show up. Oh, there it is. Okay. COM STM microelectronics. That's what we want. We're going to erase before flash. Let's look at the directions. So these are all the settings that I've just shown you. Now hold your breath, cross your fingers, press flash. So it's actually downloading the source code from GitHub, compiling it, and creating a version of the binary firmware for your particular machine, your particular radio module inside of your radio controller. And then it's going to write that to your internal module if all goes well. Sometimes builds take at least a few minutes. That's because, like I said, it's downloading it from GitHub, it's compiling it, and then it's going to save that binary locally, and then it's going to burn it. And here we go. Success. Great. All right. Now we flashed it. Now let's go back to directions. So we did that. Select category, select the method, select the firmware option, click flash. Wait for the flash. Now we did it. So now it says unplug. Unplugged it. Now, using the ExpressLRS Lewis script from the tools menu, checked if the firmware upgrade got loaded. So you can actually do that by on the radio pressing system, run ExpressLRS, and on the top it'll tell you somewhere it'll tell you the firmware version. Radio master pocket. 3.4.3 on the bottom, so it got updated. So I'm going to hit exit and return. Okay, now let's go back to the configurator. Oh, we also want to download the Lewis script, because if we upgrade the firmware in the future, the Lewis script may change. So we're going to download it. To download with the configurator. And now I need to put that new Lewis script onto the radio. So I'm going to plug the radio in, select USB storage, and let's look for the USB. Here it is. This is the SD card on the radio. Go to scripts, tools. Okay. The new one that we just created, let's open another folder from downloads. Okay. This is the downloads folder. We just created this at 11:10 a.m. 1 minute ago. So that's the newest, most up-to-date Lewis script. On the radio, we might have an older version. This one was 8:27 yesterday. So we're going to take this new one that the configurator created. Again, it's just a text file, but it may have some new code in it for the newest version of ExpressLRS. So we're going to just copy that over, and we're going to replace the one on the radio. Okay, so we did that. I'm going to eject the radio. Eject. Okay, let's go back to our directions. Copy the Lewis script over to scripts tools. We did that. Now we need to run it again on the radio just for completeness. So unplug the radio.
Disarmed. Stabilize mode.
Press the system, run the Lewis script, let it run, and then go down to exit and hit return. Okay, so that's it. The radio, it has now all the latest firmware, and so it's up to date with its firmware for the UI, HDX, and the internal radio module ExpressLRS. And the internal radio module has a passphrase that we'll be using to communicate with your drone when we bind to the receiver.